Welcome to this discussion. Today's discussion is going to be a problem solving in probability theory. Alright, so I read this first example. Suppose that the probability of obtaining A is 0.4, the probability of obtaining B is 0.3, and the probability of obtaining A union B or complement is 0.42. So the question is, are A and B independent? So here what we are going to emphasize on is the independent. Alright, so let's take the solution of this. Now for any independent variables, for instance, if you have A and B and then we said if A and B are independent, then it means if you take the probability of A intersection B, that's the probability of obtaining both A and B, it should give you the probability of A times the probability of B. Alright, so if such happens, then we can say that A and B are independent. Alright, so let's see from this question. Now from here we have been given the probability of A, probability of B, and probability of A union B or complement. So recall from your Venn diagram study that we know that the number of A plus the number of elements in B is minus the number of elements in A intersection B is equal to the number of elements in A union B. So in probability, instead of n, we make it the probability of A plus the probability of B minus the probability of A intersection B, which is equal to the probability of A union B. Alright, and also we know that the probability of A union B is equal to 1 minus the probability of A union B or complement. Alright, it's true because if you have the probability of A union B and then, or if you have a probability of A union B or complement, remember that they are the set of possible values which are in the universal set. Remember here the universal set is 1 because it is a probability. So if you sum up all the probability that you have, you need to get 1. Alright, so it means that when we subtract, if we have the complement probability, then if we subtract it from 1, what we get is the probability of that particular event. Alright, so we move on. Since we have been given we need to find our probability of A intersection. So we need to find the probability of A union B, since we have been given the probability of A union B or complement. So this is 1 minus 0.42 as given in the question, and this is going to give us 0.58. Alright, so the probability of A union B is 0.58. Alright, and also we know that the probability of A plus the probability of B minus probability of A intersection B is equal to the probability of A union B. So if we substitute the given probabilities in this equation, we are going to have 0.4 plus 0.3 minus the probability of A intersection B, which is equal to 0.58. So grouping like terms, we get probability of A intersection B to be 0.12. Alright, so we now show that P of A intersection B is equal to P of what? The probability of A times the probability of what? B. Alright, and we know that this is 0.12, which is equal to 0.4 times 0.3, and it is also 12. 0.12, sorry, it is also 0.12. Hence we say that the probability of A and what? Sorry, we say that A and B are what? Independent. They are independent events. Alright, so that gives the solution for this particular question. So I would like to end this example here. In our next video, we are going to solve another example. So don't forget to subscribe to this video channel for more videos. So thank you for watching. Bye.